Um, this is the 15th of June 2026. The time now is 10 um uh uh to 11:45 p.m. I'm speaking about unique user identifiers uh and cryptographic unique user identifier. I'm trying to develop an attack vector. Um, what is an attack vector? An attack vector uh, uh, is attack data is cryptographically uh, seeded uh, uh, state program state seeded no seeded attack vector is a cryptographically seeded telemetry hash function. So an attack vector is a cryptographic. It's a unique user identifier or graphical user identifier hash function uh, that updates on an exploitable that updates on all states of a program of a program. For example, the hash function is defined as uh, 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 CPRNG, where CPRNG is a cryptography pseudo-random number generator. The digest hex, um, uh, the update SHA-256, 256 dot digest hex. So this is a cryptographic PRNG. But the goal of this PRNG is to update on a program state. For example, when you have and to calculate the recalculate checksum for an artifact. So MD5 has been cracked. So let me give you a bit example. Uh, crypto PRNG, the digest hex, the update, the update, SHA-1, no, the update, MD5. MD5 has been broken. It's not really standard, but if there's a hash function, um, that produces an MD5 string, you can have two copies of two MD5 string that message digest 5. uh, message digest fast, which are hash functions that have the two broken systems. But if you take the attack vector, which is modeled as a tree, a tree, that verifies artifacts, and you find two MD5 artifacts, like two files. Alice, no, let's call it file one, file uh, what name of the library, Hansel and Gretel, which is a book, uh, Alice in Wonderland, two books in the library, Hansel and Gretel, and Alice in Wonderland. You have to have a way to uh, have this kind of system. So the if you see the if this library contains two books, and the library is a folder, and you verify an MD5 checksum of artifacts, and they always have a hash equal. The MD5 updates, basically based on the MD5, basically a lot of things people like gets file tree, gets file tree. The file tree is a self-balancing tree. Uh, but if you check out the is this self-balancing tree? No, I'm not really sure. If you have the same MD5 checksum and the MD5 checksum for two artifacts, cancel and get a dot PDF or .txt, cancel and get a txt and txt. They should have two different checksum based on the cryptographically seeded PRNG, CPRNG, and the object of MD5. But in some cases, because MD5 is cracked, you can have a you can tamper with if you use the attack vector. You can swap out system. For example, it's an attack. So the attack. Why is it called an attack vector? Because when you compute at a certain point of a program state, you can compute. Say you are enumerating the subroutine in an algorithm that stores a file, and you have these two files there, and you take Harrison and Gretel, the txt, and the Harrison and Gretel txt is MD5 system, and the sort. So basically, the attack works because you the crypto PRNG. Crypto is a cryptographic model in Python and you know, you take the hex dash the 25 digest. You can track the state of the MD5 digest tracking. Basically tracking something is fine now. So you have a sort. Think of it like a sort. So basically MD5 plus a sort, and that sort is the attack vector. So the attack vector is looking for exploits. So basically, if I want to replace this with a different book of this Alice and Bob, basically it's a swapping thing. It's a swapping. So you take this book is in the library, and you want to replace it with a mt.txt, but you just swap it. You swap empty dot no empty.txt my empty book dot I want to replace Hansel and Gertrude my empty book and you rename it this is possible because the sort is treated basically you apply the attack vector on the state of the program and the program is enumerated to Hansel and Gretel. So by if the if Hansel and Gretel's is broken, uh, is the MD5 hash is calculated by broken. There's an equivalent MD5 hash for the system. You can use the sort because you can compute it in real time. So you can say real time. So basically, the sort algorithm is defined as a tag vector. That algorithm is basically tracking up to the updating state of the program based on the MD5 digest. So it's a vector. It's called a tag vector because it's an equivalent MD5 string to compute given a sort. Given a sort. So I said it's an attack vector. It's a completely hash function that updates that can basically if you have a two sorts, basically if you have a sort, basically if you apply a sort attack vector sort like a sorted algorithm they'll change it a little bit. They'll change how to a little bit. You can recompute, and you can actually you can place some payload that will be equivalent to the old hash, the algorithm can have. Because the sort change because it's basically if you have two MD5 strings, like MD5, you get A1 to basically describe 256 block size. ND5 is basically 512. Two A1. Let me just no, is it 256? Uh, A1. Let me try to give you a simple example. So you have 256 256 characters long. On a string. This is ND5. And you have 256, but it's not 512. You got 256 characters long. Wait, 250 MD5 block size. Let me go with that. MD5 block size. MD5's block size. It's 512 bytes. 512 bits. So 512 bits is 64 bytes, 64 bytes long, which is 512 bits. Basically, you have 64 bytes of data equal to 64 bytes of data. Well, by comparison of the block size, you have the two equivalent algorithms that are comparing. So you have some sort basically instead of you divide and conquer problem, because you have to divide the block into 32, 32 by 32 and 32 two prime equivalents. Because you have to do price consolidation basically. If you have it's just 32 blocks, 32 bytes, 32 bytes, 32 bytes, and you have two sets of 32 bytes, but you still have 64 bytes in total. So 32 plus 32 will give you 64. But but the idea is you because you find another artifact that is equal, another artifact that has the same MD5 hash. You have to then create a sorting algorithm. Let's call it a CRN, a sorting. You develop a sorting algorithm that can overlay, that can update the hash function to the same hex digest. But that sorting function will contain a different payload, a different payload. And this one can be a random, any kind of random sequence of bytes that still represent that hash function, and that's the goal there. So, for example, if I do def create uh, create 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 func so function create prng create prng 64, and input is a seed, a seed function. Uh, where the seed function comes from? The seed function will have to take two inputs. Create prng 64, 64 blocks, 64 64 blocks, 64. So, 64 bytes of data. Uh, will basically appear into the 4 bytes of data. So, this is the one function I'm going to define here. So, the goal is to, it's possible. I know it's possible, but it's no basically the sort is added to the MD5 hash, and that MD5 hash has to go through some polar rotation. So you have to go through a lattice. You can modify a lattice and a polar lattice because they have a join and a meet at certain basically it goes back on itself because it comes pseudo random pseudo random because it's no longer random and it lines on a lattice. So you can formalize this or so you're gonna see the cd equals to 42. No, cd equals to basically cd of this window will be basically the definitions for cryptographic implementations like cprng seed seed function. So cprng, let's see, a wiki. Uh, cryptographic. So crypto. Basically, it's possible. It's doable. It's doable. Because the basically you can do some swapping. You can swap out an artifact that's been computed by an MD5 checksum if MD5 is broken. If the artifact, because MD5 is broken, because it's needed, basically, it's, if you swap out, if you can compute an MD5 artifact, you can develop basically the artifact, so basically, they verify the MD5 checksum of a system. Basically, you have an MD5 checksum, and the MD5 checksum is computed already. Wow, I was like, think of it like a Docker pool or Git pool, Git clone. There's an MD5 checksum for each artifact, and if you can, in the network, if you can say you are, Git cloning, and this artifact, Hansel and Gretel dot txt is what you wanna replace. The MD5 thing is computed, by the system gets a 512 block size, 512 block size. Uh, but the goal of the is to swap out Hansel and Gretel. So you replace with Brook. So you want to compute another prime number, something that's equivalent to MD5, but with a different payload, and that would be what you replace with. Whilst it's executing the other operations on other artifacts. Yeah, that's the idea. It's kind of malicious, but I call it an attack vector because it's basically having the same MD5 string, MD5 string, but it contains it's an attack on the state of the program. So you can complete a sort basically. It takes a sort and a vector. So the sort will be the thing that changes plus the vector, which is basically the state of the program in hexadecimal. Basically, because the how you attack the hash function. And hash function is basically hexadecimal. So the vector will be so basically once you get to that program state, like when you start cloning the artifact, which the program state here, you can run an arbitrary program on the payload, on what is doing that stuff, and that will be the vector. So that's called an attack vector. So you can use it to like dimension. You can use it to have a framework for taking stuff apart. But or some kind of a download from a different resource, or but it's kind of malicious, but it is what it is. It's still a target. So you got other things you can address in it. You can have it's not kind of I haven't really developed the algorithm yet. I'm not really bothered to develop it, but it's what it is. What I've been thinking about. But it couldn't attack with them. So it can attack it can withdraw assets and let you because if you can have a different asset with just a memory, you want to swap out, and you have a perfect working station, then you can you can hijack a system, take over control of the whole you can replace you can do code injection code injection because MD5 string is the concept needs to be developed a bit further, but you can do code injection because malicious code injection because the artifact already have the same checksum and what it's basically doing is tracking the state of the program. It's basically enumerating the state of the program, not just tracking it. By ensuring that the sort the state of the program matches the hash function. Insane.